Problem 11, summation n is equal to 0 to infinity of n squared over n plus 1 factorial. Whenever I see a factorial, I typically go to the ratio test. So you take a limit as n approaches infinity of the n plus 1 term over the nth term. A little tricky sometimes. N squared becomes n plus 1 squared. N plus 1 factorial becomes n plus 1 factorial. And again, you have the nth term down below, which is just the n squared over n plus 1. When you flip-flop this, you end up getting an n plus 1 squared on top, along with the n plus 1 factorial, over n squared times n plus 2 factorial, which sometimes can be a little tricky to simplify. Taking a look just at the n plus 1 factorial over n plus 2 factorial, n plus 1 factorial means n plus 1 times n minus 1 until you get all the way down to 1. N plus 2 factorial has just one extra term of n plus 2, then n plus 1, and etc. down to 1. So you can cross out the n plus 1 and all the way down to 1 at top and bottom, and it just leaves 1 over n plus 2. So that leaves, the limit as n approaches infinity, the n plus 1 squared is still on top, the n plus 1 factorial up top disappeared, the n squared still there, and again the leftover term of n plus 2 on the bottom. Looking at the highest powers, the top of that fraction is going to be n squared followed by some other terms, and on the bottom you'll have an n cubed followed by another term, and that limit, since it's bottom heavy, is 0, which is less than 1. And the ratio test tells us if we get an answer of a limit less than 1, we get convergence, so this series converges to approximately 1.7183.